11 kilometers per second. That is the speed a national observatory assigned to an enormous ring-shaped object, it says. It filmed moving over the lunar surface. Lunar escape velocity is 2.376 kilometers per second. That object is not based at the moon. It is leaving forever at more than 4 times the speed required, and that directly contradicts the paper's own conclusion. That is the second of 4 problems with this claim. The fourth is the one the observatory already put in writing. A preprint is circulating right now, claiming that more than 20 unidentified objects have been filmed moving on and around the moon. It is titled UFO Dynamics on the Moon. It carries a real digital object identifier. It is hosted on the website of a national observatory, and the name attached to it belongs to a working astronomer with a doctorate in physical and mathematical sciences. That combination is why this one traveled. Most claims like this arrive from an anonymous account with a compressed video. This one arrived with an institution's name on the letterhead. The observatory is the main astronomical observatory of the National Academy of Sciences of Ukraine, outside Kyiv. The lead author is Boris Efimovich Gilyaev, associated with the observatory's Laboratory for Transient Phenomena in Stars, with co-authors Vladimir Petukov and Sergei Pokhvala. All of that is real and verifiable, and none of it is in dispute. The paper reports high-cadence telescopic video of the sky immediately around the moon and of the lunar disk itself, recorded mainly on the 7th of September, 2025. Across those frames, the authors say they found more than 20 distinct objects, sorted into 2 categories. The first category they call atmospheric. These appear more or less fixed against the lunar disk, flashing for somewhere between 100 and 500 milliseconds at roughly 1 stellar magnitude, with light curves showing harmonics clustered around a few hertz. The stated sizes run from hundreds of meters up to several kilometers. The second category is where this story lives. The authors call them continental objects and describe them as moving across the lunar surface itself. Disc-shaped examples are assigned diameters of roughly 25 to 40 kilometers. One ring-shaped object, a toroid, is given a diameter near 36 kilometers, a speed of up to 11 kilometers per second, and a rotation period of about 180 seconds. The paper describes these objects as heavily camouflaged, nearly matching the moon in color and brightness, with contrast frequently at or below 10%, and in places as low as 3 to 5%. To pull them out, the authors use false color rendering, frame alignment, and a Fourier technique they call phase discrimination. Their conclusion, stated plainly in the paper, is that the moon may function as a base for a technologically advanced civilization, and that smaller craft dispatched from it could reach Earth in about 20 minutes. The paper is not peer-reviewed. Hold on to that, because the ending of this story turns on a very specific and very uncomfortable version of that fact. The single most important detail in this entire story is not in the conclusions. It is in the equipment list. The observations were made with an Intes Alter M603 fitted with a cooled CMOS camera. That telescope is a Maksutov Cassegrain with an aperture of 152 millimeters and a focal length of 1,500 millimeters, working at f10. In plain terms, it is a 6-inch backyard telescope. It is a good one. Well-regarded, sharp optics, about 2 meters of tube and 6 kilograms of mass. But it is an amateur instrument. It is not a research telescope, and the paper does not claim it is. Here is why that matters more than anything else in the document. Aperture sets a hard physical ceiling on how much detail a telescope can resolve, and no amount of processing lifts it. You cannot Fourier transform your way past diffraction. The number is fixed by optics the moment you choose the mirror. For a 152 millimeter aperture at green wavelengths, that limit is about 9/10 of an arcsecond. At the moon's mean distance of 384,400 kilometers, 1 arcsecond covers about 1.86 kilometers of surface. The very best this telescope can resolve at the moon is therefore roughly 1.7 kilometers. And under realistic 2 arcsecond seeing, which is a decent night rather than a bad one, that degrades to about 3.7 kilometers. So we now have 2 numbers sitting next to each other. The telescope resolves, at absolute best, 1.7 kilometers, and the paper says it captured an object 36 kilometers across. Those 2 numbers are about to have a collision. Let's do the arithmetic the paper invites us to do, because this is checkable by anyone with a calculator. An object 36 kilometers across, sitting at the moon's distance, subtends an angle of 19.32 arcseconds. To give that scale some meaning, Jupiter at its closest approach to Earth spans about 50 arcseconds. Mars at its very best spans about 25. So the claim is of an object roughly 40% the apparent width of Jupiter. moving across the surface of the most photographed object in the entire sky. The smaller disks do not help. 25 kilometers works out to 13.41 arcseconds, 40 kilometers to 21.46. Now put that against the telescope's resolution. If an object 19 arcseconds wide were genuinely sitting at the moon, that 6-inch telescope would spread it across roughly 20 resolution elements. 20. It would not be a marginal detection at 3% contrast, requiring false color and Fourier phase discrimination to coax out of the noise. It would be an obvious dark structure, unmistakable in a single raw frame, and it would not be visible only to one telescope on one night. Tens of thousands of amateurs image the moon at high frame rates every clear night because the moon is bright, close, and rewards cheap equipment. At every professional lunar monitoring program currently operating, not one of them has reported this. Not one independent detection from any observer anywhere, at any aperture. That is the first hole, and it is not a small one. An object cannot be simultaneously large enough to be a 36-kilometer craft and faint enough to require heroic signal processing to see. The claim contains its own contradiction, and it gets worse from here. The second problem is the one that ends the argument on its own terms because it does not require any outside data at all. It only requires taking the paper's own headline number seriously. The paper says the toroidal object was moving at up to 11 kilometers per second. Lunar escape velocity is 2.376 kilometers per second. That is the speed at which an object stops being bound to the moon and leaves permanently. Circular orbital velocity, skimming just above the lunar surface, is 1.68 kilometers per second. 11 kilometers per second is 4.63 times lunar escape velocity. Sit with what that means. An object traveling at that speed immediately above the lunar surface is not orbiting the moon. It is not hovering, patrolling, or stationed anywhere near it. It is on a hyperbolic trajectory, departing forever, and nothing short of a sustained engine burn brings it back. The paper's conclusion is that the moon is a base. The paper's own velocity figure describes an object leaving the moon at more than 4 times the speed required, never to return. Those two statements cannot both be true, and they appear in the same document. A second consequence is buried in that speed. At 11 kilometers per second, the object sweeps about 5.9 arcseconds every second, and the full lunar disk is 3,474 kilometers across, so it crosses the entire face of the moon in 316 seconds. A little over 5 minutes. Picture that. A dark structure 19 arcseconds wide, taking 5 minutes to walk across the face of the moon, in an era of continuous imaging by thousands of cameras. It would be the most captured event in the history of amateur astronomy. Instead, it appears in one dataset from one instrument at one site. The third problem only shows up when you read the companion papers, and it is the kind of error that is very hard to explain away. Zhilyaev and his collaborators have released a series of related preprints, not just the one going viral. They describe the same catalog of objects, which means the same object shows up in more than one document, and the numbers assigned to it do not match. The physics here is not exotic. Centrifugal acceleration on a rotating ring is 4 pi squared times the radius, divided by the period squared. It is a one-line formula with no room for interpretation. Take the toroid as described in the paper that went viral, 36 kilometers across, so an 18-kilometer radius, rotating with a period of 180 seconds. Run the formula, and you get 21.93 meters per second squared, about 2.24 times Earth gravity, matching what that paper reports. So far, internally consistent. Now take the companion preprint. Same object, same stated diameter, but a rotation period of 157 seconds. A shorter period means a higher acceleration. That is unavoidable. The correct answer for those inputs is 28.83 meters per second squared, or about 2.94 times Earth gravity. The published figure is 461 centimeters per second squared. That is 4.61 meters per second squared. It is roughly 6 times too small. You can work backwards and ask what object would actually produce that number. 4.61 meters per second, squared at a 157 second period, implies a radius of 2.88 kilometers. A ring, 5.76 kilometers across, not 36. So the two papers describe the same object as either 36 kilometers wide or about 6 kilometers wide, depending on which page you are reading. And neither figure reproduces from the parameters the authors themselves supply. That is not a disagreement about interpretation. That is arithmetic that does not close. The fourth problem is the deepest one, and once you see it, you cannot unsee it anywhere in this series. Every single size in every one of these papers is derived, not measured. The telescope measures one thing directly: angular size, how wide something appears on the sky. To convert an angle into an actual size, you must know how far away the object is, and to estimate distance from brightness, you must assume how reflective it is. Distance and albedo. Two assumptions, and every headline number in the series rests on both. That same 19.3 arcseconds, the angular width the authors convert into a 36-kilometer lunar object, is produced exactly as well by an object 1.87 centimeters across at 200 meters, or 9.4 centimeters at 1 kilometer, or 94 centimeters at 10 kilometers, an insect at 200 meters, a bird at 1 kilometer, a fragment of windborne debris drifting through the light path a few kilometers up. Each produces an angular signature indistinguishable from a 36-kilometer structure at the moon in a single-site image every time. Nothing in a photograph taken from one location tells you which of those you are looking at. The image contains no depth information whatsoever, and no processing technique can manufacture it. Exactly one measurement resolves this, and it has been known for centuries. You observe simultaneously from two stations, separated by a known baseline, and measure the parallax shift. That gives you distance directly, with no assumption required. That measurement does not appear anywhere in this series, and as we are about to see, somebody already pointed that out 4 years ago in writing from inside the same building. This is the part almost every article covering this story leaves out, and it is the part that decides it. The framing you see online is that this paper is being suppressed, that mainstream science refuses to engage, refuses to review, refuses to look. The record shows the exact opposite. This methodology was formally reviewed at the author's own institution, and the institution put its findings in writing. After an earlier preprint from the same group appeared in 2022, the Main Astronomical Observatory convened an astrophysical seminar on the 15th of September that year, with Zhilyaev present, to examine the argument that the observed events were genuinely unidentified. The observatory's scientific council then issued a formal statement. The council allowed that the observations themselves were, in their word, original, but it found that, quote, processing and interpretation of results were performed at an inappropriate scientific level and with significant errors in determining distances to the observed objects. Errors in determining distances, that is the exact failure we just walked through, identified 4 years ago by the people whose institutional name is on the paper. The council did not stop there. It listed the specific defects, absent dates, no indication of which events had been observed simultaneously from the group's two stations at Kiev and the village of Vinarivka, and no argument addressing whether ordinary phenomena might account for the detections. The statement names them directly: meteors, objects carried long distances by wind, space debris, and instrumental artifacts. The Academy's own assessment went further. It called the article, quote, pseudoscientific in form and content, said the methods are simply full of inaccuracies, simplifications, fabrications, and outright manipulations, and said the conclusions are mostly absurd, far-fetched, and have nothing to do with simple natural explanations of observed phenomena. Following that seminar, the Scientific Council required that the paper, permitted to remain hosted on the observatory's website, be revised to state that the authors alone were responsible for an independent study, conducted with no participation of the observatory. Avi Loeb of Harvard published a separate analysis of the 2022 claims, bringing them and his framing back down to earth. The Skeptical Inquirer covered the episode that December, so the honest description of the paper currently going viral is not that it is unreviewed. It is that this methodology was reviewed once at the institution named on it and rejected in writing, and the paper is circulating anyway, carrying the institutional affiliation that the institution specifically instructed be qualified. The suppression story is not just unsupported, it is precisely backwards. None of this means professional astronomy refuses to look at the moon for strange things. It means the opposite, and the contrast is worth understanding, because it shows you exactly what standard this footage was measured against and failed. Astronomers have been logging anomalous lunar events for 4 centuries. They are called transient lunar phenomena, brief flashes, glows, reddish colorations, patches of obscuration that appear and vanish. Serious observers, including professionals, have reported them since the invention of the telescope. The term was coined by Patrick Moore as a co-author of NASA Technical Report R277, the chronological catalog of reported lunar events, published in 1968. Winifred Cameron extended the work in 1972, cataloging 1,468 reports after discarding events with obvious causes. and sorting what remained into gaseous obscurations, reddish colorations, blue-violet colorations, and brightenings. The most famous case belongs to Nikolai Kozyrev, who in 1958 obtained a spectrogram of the crater Alphonsus, interpreted at the time as gas venting from the surface. The crater Aristarchus remains the most frequently reported site on the Moon. Modern analysis treats most of that catalog as observer error, atmospheric effects, and illumination geometry, with a small residue nobody has explained. That residue is a genuine open question in lunar science, and it is being worked on right now. The modern version of that hunt is where the comparison becomes brutal. Neliota is funded by the European Space Agency and operated by the National Observatory of Athens on the 1.2-meter Crionary telescope. Since February of 2017, it has run twin cameras recording simultaneously in 2 separate photometric bands at 30 frames per second, specifically to catch and validate impact flashes on the unlit lunar surface. It has now validated more than 190. The 2-band requirement is the entire point. If a candidate flash appears in one channel and not the other, it is not a lunar event. It is a cosmic ray hitting the sensor, or a satellite glint, or noise. The second camera exists to kill false positives. That is the professional standard for calling something on the Moon real. Build the machine so it can prove you wrong. Now compare. 1 telescope, 1 site, 1 channel. No simultaneous second station, no parallax, no independent corroboration from any of the thousands of people pointing cameras at the same object on the same nights. The footage does not fail the standard by a little. It never entered the room where the standard is applied. One more thing gets folded into this claim constantly. In March of 2025, Firefly Aerospace's Blue Ghost lander captured the first high-definition imagery of a lunar sunset from Mare Crisium, showing a distinct glow above the horizon. That glow is real and not fully modeled. It is lunar horizon glow. Sunlight forward scattered off dust lifted electrostatically off the surface. The Apollo 15 and 17 crews saw it with their own eyes, Eugene Cernan among them, and Surveyor 7 photographed it in 1968. It is an unsolved problem in lunar physics. It is not a light from a base. Here is the part that makes this whole episode genuinely costly, rather than just annoying. The Moon actually is strange. Its real measured properties do not fit the story we tell about it, and the manufactured mystery is currently drowning out the authentic one. Start with what the Moon is made of. Earth's mean density is 5.514 grams per cubic centimeter. The Moon's is 3.344, about 60.6% of Earth's. The Moon carries roughly 1.23% of Earth's mass, making Earth about 81.3 times more massive than its own satellite. That is an extreme ratio for a planet and moon pair. Then there is the interior. The moment of inertia factor tells you how mass is distributed inside a body. Earth's is 0.3307. The signature of a large iron core concentrated at the center. The Moon's is 0.3931, close to the 0.4 you would expect from a body of nearly uniform density throughout. Density, moment of inertia, rotational signature, and magnetic induction response together constrain the lunar core to less than about 25% of the Moon's radius. Rene Weber and colleagues reprocessed the original Apollo seismic data in 2011 and resolved a solid inner core near 240 kilometers in radius, with a fluid outer core near 330. The Moon has a core. It is just far too small for a body that size. The leading explanation for all of that is the giant impact hypothesis. A Mars-sized body called Theia strikes the young Earth. The collision throws silicate mantle into orbit while leaving Earth's iron-nickel core largely intact, and the debris coalesces into the Moon. That story accounts neatly for the low density and the undersized core. Then the Apollo samples came back, and the story developed a problem it has never fully shaken. Lunar rock is isotopically almost indistinguishable from Earth's mantle. Not similar, nearly identical, across oxygen, titanium, chromium, and tungsten. Daniel Hurwitz and colleagues measured the oxygen isotope difference between lunar and terrestrial rocks in 2014 at 12 parts per million, give or take 3. Junjun Zhang and colleagues found the lunar titanium ratio within a few parts per million of Earth's in 2012. The debate is still live. Eric Kano, Zachary Sharp, and Charles Shearer argued in Nature Geoscience in 2020 for distinct compositions, and a paper in 2024 came down on essential identity. The trouble is that canonical impact models predict a moon built substantially out of Theia, a different body formed elsewhere in the solar system with different isotopes. That should have left a large, obvious chemical signature. It did not. Reconciling the two requires near-perfect mixing of the debris, an unusually specific impact geometry, or a Theia that happened to be an isotopic twin of Earth. The literature calls this the isotopic crisis. That is a real unresolved question about where the moon came from, sitting in the peer-reviewed record right now, backed by returned samples and measured to parts per million. It requires no camouflaged craft, and nobody filming anything, and it is getting a fraction of the attention a rejected preprint is currently getting. So where does this leave the claim, and what would actually resolve it? One measurement ends the argument permanently, and it is neither expensive nor exotic. 2 stations, separated by a known baseline, observing the same patch of sky at the same instant with synchronized timestamps. The parallax shift between the 2 records gives you distance directly, no albedo assumption, no distance assumption, no processing. An object at the moon shows essentially 0 shift. An object a kilometer up shows an enormous one. One clear night settles it forever. The group operates 2 stations at Kiev and Vinarivka. The Scientific Council flagged the absence of simultaneity information 4 years ago. That measurement still has not been published. Until it is, every size and velocity in this series remains an assumption wearing the costume of a result. The other thing missing is an independent frame-level artifact analysis. Nobody has published one for the September 2025 video. The likely mundane mechanisms are well known. Brightness modulation from atmospheric seeing, oscillation in the telescope's tracking, sensor artifacts, near-field objects crossing the light path. And specialists point at them, but no one has done the tedious work of proving which one it is in print. That gap is exactly the space the claim is living in. If you want to look at the moon this week and see something genuinely remarkable, there is a better target. Next Wednesday, the 12th of August, a total solar eclipse crosses northern Siberia, eastern Greenland, the west coast of Iceland, northern Spain, and a small corner of Portugal. The moon's shadow is 293 kilometers wide, and it runs an 8,260-kilometer track in 1 hour and 36 minutes. Maximum totality lasts 2 minutes and 18 seconds, over ocean west of Iceland. Burgos, Leon, and Valladolid get roughly 1 minute and 45 seconds, with the sun eclipsed shortly before it sets. That happens because of a coincidence measured to millimeter precision. The sun's diameter is about 400.7 times the moon's, and the sun is about 389 times farther away. The 2 ratios nearly cancel, so the disks match. Laser ranging off their reflectors, left by Apollo 11, 14, and 15, puts the moon's recession at 3.8 centimeters per year, which gives totality an expiration date around 600 million years out. That geometry handed us helium, identified in the corona's spectrum during an eclipse in 1868, before anyone found it on Earth. It is what let Arthur Eddington confirm general relativity in 1919. Real, checkable, and available to anyone standing in the right place next Wednesday. The lesson here is not that people are gullible. It is that an institution's name on a document does enormous work, and that the institution's own written rejection of the method travels a small fraction as far as the claim does. The arithmetic was always available. It takes about 10 minutes and a calculator, and it is the single most useful thing you can do the next time a paper like this lands in your feed. We will be watching for that 2-site measurement. If it ever gets published, it will answer this in a night.